Weather and climate. What's the difference between weather and climate?
Weather is the average condition of the atmosphere in a certain place over a short period of time. The weather can change from day to day. It is affected by different factors like air temperature, air pressure, wind, clouds, and others.
While climate is
First, the average or typical weather condition in a particular place over a long period of time. It changes in years or even centuries. Different regions on Earth have very distinct climates. There are several factors to determine them, such as latitude and tilt of Earth, altitude and elevation, extreme currents and temperature, wind system, precipitation, air masses, and mountain latitude and tilt of Earth. Sunlight hits Earth's surface at varying angles due to Earth's shape is an oblong spheroid. The angle at which the sun rays strike Earth varies from region to region. The sun appears directly above the equator at a high angle. This is why places near the equatorial region generally experience a warm climate. In the polar region, the sun shines at very low angle. Thus, places in the polar region experience the coldest climate. Between the equator and the poles, the angle of the sun varies greatly due to the tilt of Earth on its axis at 23.5 degrees. The places that are near to the equator experience tropical climate.
Altitude or elevation. Another factor that affects the climate of a region is elevation. Elevation or altitude refers to how high a region is from the sea level. The higher the elevation, the colder is the climate.
Ocean currents and temperature. A body of water such as an ocean and its currents also affect the climate of a particular place. Ocean currents tend to increase the temperatures of eastern coastal areas and decrease the temperatures of western coastal areas. The surface temperature of a body of water also affects the temperature of the places that surround it, because large bodies of water change temperature slowly. Places near the seacoast have milder winters and cooler summers. Precipitation. The amount of humidity of water vapor in the air determines the amount of precipitation in the area. Commonly, when the atmosphere becomes full of water vapor, there is more chance of precipitation to occur. Water vapor is formed when water evaporates. Evaporation can occur on oceans, seas, rivers, or even on a puddle of water. Rainfall plays a significant role in the eliminate of a region. When water vapor rises in the air, it collides with other water vapor and form clouds through the sky. For example, heavy rainfall mostly takes place at rainforests, while deserts receive minimal rain in a year. The precipitation in an area depends largely on the winds that cross over the region.
If you want to know about the weather, you really need to know about things called air masses. But, what with it being see-through and all that, air is a pretty difficult thing to look at. So first of all, what exactly is an air mass?
Well, an air mass is a name given to a large chunk of air that develops certain characteristics because of where it is on the planet. For example, air that sits over North African deserts is very hot and dry. We call this type of air a tropical continental air mass because it's in the tropics and it sits over the continental land rather than over the sea. With the right weather patterns, this air can come all the way to Britain. As it moves north, it has to cross the Mediterranean Sea, Spain and France, but it will still keep some of the dry and hot characteristics it originally had. So, a tropical continental air mass brings us dry, warm and mostly clear skies. It might bring more than just good weather, as this sort of air mass can give spectacular sunsets and deposits of fine red dust on the ground if it's picked up desert dust from the Sahara. Another easy one to spot is a polar continental air mass, and the name describes exactly what it is. This air mass is called polar because it comes from around the North Pole, and continental because it travels over the land rather than the sea. If this air mass makes it to the UK, it could have come from two different directions, either from the east, moving south from the pole across Siberia and Eastern Europe, or it can come from the northeast, travelling across Scandinavia before it gets to us. This air mass brings some of our coldest weather in the winter. At the end of 2010, the UK was in the grip of a polar continental air mass, and temperatures plummeted to a very chilly -18 degrees Celsius in Wales, the lowest on record for November.
On their journey to us, often across the North Sea, these sorts of air masses can often pick up enough moisture to create really heavy snow showers on the east coast. In Northumberland, on the 30th of November 2010, one of these air masses dumped 40 centimetres of snow. 40 centimetres! But what about weather with a journey over water? Any air mass that travels over the sea will change dramatically on its journey to us.
Polar maritime air arrives from Britain from the northwest. It starts over northern Canada or Greenland, where it's cold and usually pretty dry. However, its long journey over the Atlantic Ocean means the character of the air mass changes dramatically. As the maritime air mass travels across the warm sea, the air is heated and moistened from below. Warming causes the air to rise, and as the air rises, it cools, condensing moisture in the air, forming clouds. When this air mass arrives in the UK, we tend to get a mixture of sunshine, rain, hail, sleet, and even sometimes snow. As we are so familiar with this sort of mixed weather, it's not a surprise to find out that this is one of the most common air masses over the UK. When we hear forecasters predict sunshine and showers, it's probably because polar maritime air is on the way.
We've looked at 3 of the 6 main types of air mass we experience in the UK. When an air mass originates far from us, it'll change on its journey to us. A continental air mass moving over land may alter only a little, whereas a maritime air mass alters massively as it interacts with the sea. Some air masses don't take a direct route to us and will alter as they move over warm and cold seas. The most severe weather we experience comes when cold, dry air from the north clashes with the warm, humid air from the tropical oceans to the south. We don't have enough time to look at every possible air mass in this film, but we've had a look at the basic types and how they change. If you want to learn more about air masses or anything to do with the weather and climate, why not visit the Met Office website?
Mountain barriers. The presence of mountain barriers also affects the climate. Mountain areas are generally colder than the surrounding land due to their elevation. Mountainous regions block the flow of air masses, which rise to pass over the higher terrain. The rising air is cooled, which causes condensation of water vapor and precipitation. This causes one side of a mountain, windward side, to have more precipitation and radiation, and the other side, leeward side, to be often dry.
Tropical climate zone. This zone is also known as the low latitude zone because it is found near the equator. The tropical zone is characterized by both high temperatures and humidity levels. Its average annual temperature is 18 degrees Celsius. During the day, temperatures in the region can exceed 35 degrees Celsius.
Temperate climate zone. This zone is also known as the middle latitude or mid-latitude zone and found between the Arctic and polar regions in the tropics. Places in the temperate zone that are farther from the equator may experience snow during the winter months. Meanwhile, places near the equator may experience rainfall throughout the year. The average annual temperature in the temperate zone ranges from 5 degrees Celsius to 20 degrees Celsius. Countries within this zone have 4 seasons: winter, summer, spring, and autumn or fall. Polar climate zone. This zone is also known as the high latitude and is found between 60% latitude and the poles, or north and south poles. The average annual temperature in this zone is below the freezing point or 0 degrees Celsius. Most places in the polar climate zone are covered with glaciers or layers of ice. Precipitation that reaches 25 cm occurs yearly in this zone, making it dry.
In this animation, we're going to look at the cycle of El Nino and La Nina. That is a pattern that occurs regularly in the Pacific Ocean and has a huge effect on climate and rainfall and other kinds of activity all around much of the world, especially around the Pacific Ocean. Now, in order to understand the development of these two conditions, El Nino and La Nina, let's take a look at what the normal situation is in the Pacific Ocean. Normally what happens is that you can see those reddish arrows there. You get these very strong southeast trade winds blowing from east to west across the Pacific. By the way, this is North America over here, South America. This red line represents the equator. This is Australia and New Guinea, and Asia would be out of view on this side. So as these trade winds blow, the air eventually rises in low pressure systems and creates a lot of rainfall over on the west side of the Pacific, over near Indonesia. And as that water, and what happens is a circulation cell called the Walker cell is set up here that it basically runs like that. Well, the effect of that is to push the water away from South America. Ocean surface currents are pushed this direction, and that takes warm water and pulls it away to the west, and it lets cold water come up from below. Here we have warm water, the thermocline, the big change from warm to cold, and then cold water down underneath. And as that wind blows and pulls the water away from South America, you tend to get cold upwelling water near South America. Meanwhile, a lot of very warm water accumulates over here in the western Pacific. It's called the West Pacific Warm Water Pool, because that water takes a long trip along the equator and it gets very warm in this area. So this is a part of the world that's very wet and warm and rainy, whereas this part of the world tends to be cool and drier in general. Now, the whole reason this can happen is because these strong trade winds push this water from east to west. But if those trade winds break down, what can happen is all this warm water on this side of the Pacific Ocean can kind of slosh back across and pile up on this side. And that's really what happens during an El Nino. What happens during El Nino is the trade winds actually weaken and break down. It's called the Southern Oscillation. What will happen is that water, that warm water, there's nothing to hold it back anymore, and it flows across the Pacific and kind of piles up over on this side of the Pacific, going all the way up toward California, all the way down to Peru and Chile. And we don't get upwelling anymore over here, and the atmospheric pressure patterns switch. And so what happens now is that warm water fuels rain and storms, and the trade winds are actually reversed in direction, and this part of the ocean now becomes the rainy, stormy side of the ocean. And so during an El Nino, we typically have very high rain, lots of storms and flooding over on this side of the Pacific, from California on down to South America. Now, what usually happens within a year or so after the El Nino is that it's like the pendulum swings back the other way, and we get a La Nina. La Nina really can be considered to be a sort of an intensification of the normal conditions. Remember, this is the normal situation where the trade winds are blowing all the water west and it's piling up over here. During a La Nina, the trade winds blow even more intensely, and even more cold water gets pushed west, and even more intense upwelling happens along the coast of South America. So it really is just an intensification of the normal situation. So the Pacific Ocean kind of oscillates between these two conditions: the El Nino condition, in which the water sloshes over to our side of the Pacific, bringing storms and rain and warm water, and the La Nina condition, in which the water goes back to the other side of the Pacific and cold upwelling becomes even more intensified. These cycles go back and forth, not particularly regularly, but anywhere from every 2 to 8 years is pretty typical.